Hi, good afternoon, everyone. Thanks for joining in the hub. So today I want to talk a little bit about the Center for Advanced Aviation System Development, or CAASD. We are the FAA's FFRDC, or Federally Funded Research and Development Center, so I want to tell you about the scope of the work that we do as part of that mission. So today, MITRE operates 6 different federally funded research and development centers. There's the very first was the Center for National Security, working with the Department of Defense. The Center for Advanced Aviation System Development, the FAA's FFRDC, then came around in 1990. The Center for Enterprise Modernization, or CEM, works with a number of government agencies, including Department of Justice, Veterans Affairs, IRS, and so they're looking at modernizing their enterprise systems. There's also a Homeland Security FFRDC that became an FFRDC more recently. The Health FFRDC works across health and human services. And then lastly, we have a National Cybersecurity FFRDC with the National Institute for Standards and Testing, NIST. So FFRDCs, if anyone's not familiar, there are a number across the US. I should probably know the total number off the top of my head, but Sandia National Labs is another FFRDC, for example, as is Jet Propulsion Labs. So the idea is that these are not-for-profit organizations that are working in the public's interest, and our mission is to support the government agencies to which we serve. We're bringing objective data and evidence to those agencies. Like I said, we don't build products, we don't sell things for a profit, but instead are providing that objective data to support the American public. So within the MITRE organization, we do have a corporate structure that works across all of these FFRDCs, and I certainly won't bore you with the details of that. Within the MITRE public sector, we have a number of centers that are serving our FFRDCs, including the Center for Integrated Transportation, which is where the CAASD FFRDC resides. One of the things I wanted to note is that while we do have these centers that largely map to our FFRDCs, we do work across those centers within the organization as well, because you could imagine that there's some challenges that are overarching all of these FFRDCs. So for example, acquisition management is certainly a challenge for the government as they figure out how to acquire new systems. Things that are being learned within the DoD FFRDC can be applied to the FAA and vice versa. Also, a lot of new software development, DevSecOps, different agile software engineering practices are common challenges for all the government agencies. So being able to share lessons learned across those government agencies is significant. And MITRE really brings kind of a whole of government perspective given all of the government agencies that we work with. So when you do have some cross-cutting challenges such as surface-to-space operations for launch vehicles, that's touching a number of government agencies. So Department of Commerce, which includes the National Oceanic and Atmospheric Administration. It touches the FAA and the Office of Commercial Space. It touches the DoD, who previously managed the space catalog, but also has concerns about DoD assets. And so being able to bridge the gap across a number of government agencies within the same organization is a benefit. I'll also point out the MITRE National Security Sector, which includes the support for the DoD, but also the JASONs, which, if anyone's not familiar, this is a long-standing organization that brings together experts across the country to work on matters of national interest. And then MITRE Labs provides some these innovation centers that have discipline-focused areas that support the various work programs for the government agencies. We also have an independent research and development program that spans all of the company across the FFRDCs. And so this is an opportunity for us to take some of the dollars that are brought in from the work with the government to be more forward-thinking on some of the problems that are going to start to affect the government, but perhaps there's too much risk involved. So this is an opportunity to buy down some risk on some of the forward-thinking research. And then lastly, we have technology fellows, which are are eminent, like many other companies, that are eminent technical folks that are overseeing some of our technical work too, and strategic thinking. I'm trying to advance the slide. Oh, there we go. Okay, so CAASD, if I go back to the FAA's FFRDC, CAASD was established in 1958. Prior to that, MITRE was working on some interests for the Federal Aviation Administration, but it was a burgeoning agency at that point. So once the importance of the FAA to manage the nation's air traffic became apparent, CAASD became its own FFRDC, formalized in 1990. We currently have 354 employees, so it's not a huge organization, but as I mentioned, we do draw from expertise across the country, or the company. And then what's important to note, I said this earlier, it is intended to be a conflict-free environment. We're not for profit, we're not competing with profit-driven companies or corporations, but rather bringing solutions to the government in an objective way. So we are part of that broader ecosystem of FFRDCs in the US. So we have a long history of mission impact. So early on, MITRE was working on some of the early air navigation and surveillance systems. So you may be familiar with the traffic collision avoidance system that's installed on every commercial aircraft in the country and worldwide. So MITRE did a lot of the early standards development work for TCAS. Between 1990 and 1998, there was a lot of work on traffic flow management. So if you ever had a ground delay or a ground stop for your flight, that refers to some of the traffic flow management. So really, dealing with weather disruptions and other disruptions. So CAASD did some of the early work on the automation systems that help support those decision makers. Also worked on the free flight concept, as well as oceanic air traffic control, so really putting the systems and procedures in place to support oceanic management of air traffic. Between 1999 and 2005, started to look at area navigation and required navigation performance, so this gets into GPS-based navigation of air traffic, as well as the instrument flight procedures that aircraft fly. Also telecommunications, and then airspace redesign, which gets into where are the facilities located, how are the airspace sectors designed, really to handle traffic in high density areas and ensure a workable problem for air traffic controllers. 2006 to 2011, started to get into ADS-B, so Automatic Dependent Surveillance Broadcast. So this is a GPS-based surveillance system that was mandated on all aircraft operating in certain classes of airspace starting in 2020. Also, we're looking at ASIAS, was an aviation safety reporting, voluntary safety reporting program. So airlines were contributing data to this and the data is anonymized and then used to identify potentially unsafe conditions in the national airspace and how can we mitigate those. So kind of proactive safety monitoring. And so that's about when I joined MITRE. I joined in 2009, so I started working on ADS-B applications, so some flight deck applications that leverage the surveillance that's now available to air traffic. I also work on some of the evaluation of the PBN procedures, looking at how these automation systems would be designed to take into account new technologies. And then in 2012 to 2017, started to get into what we call trajectory-based operations. So this is just leveraging this more information that we know about all the flights, the precision that comes with GPS navigation, and how do we take advantage of that to increase the density of air traffic. 2018 to 2022, starting to get into the COVID era, starting to look at what is the future of airspace and what are these new entrants that will be operating in the airspace and have to be effectively integrated with legacy air traffic. Surface to space, of course, referring to management of launch vehicles through the airspace. What do procedures look like? What do automation systems are needed so that air traffic controllers have awareness of those launch vehicles and airspace closures? And then today, it's kind of funny that we have a 2018 to 2022, and then there's like a spike of today. But if anyone's paying attention to the news, you know that there's a lot going on with the FAA and replacing some of the legacy systems that are in place. There has been a significant injection of funding from Congress to replace some of the voice communication systems, the aging radar systems, and so a lot of effort around this ATC modernization, I think, will be happening over the next couple of years. What will be really important is to think about how do we position the national airspace for the future so that we can continue to incorporate those new entrants like small UAS, air taxis, increased number of launch vehicles. So lots of need for some urgent replacement of the aging infrastructure, but forward thinking about how to accommodate the future. Air traffic controller training is another effort that MITRE's working on. So that's another thing in the news as well, is the number of air traffic controllers that are needed. Part of the barrier to that is the lengthy time it takes to train and certify someone for a facility. So looking at new ways that you could maybe speed up the training, but also keep folks current, prepare them to operate in new airspace, for example, or new facility. So a lot of thoughts about what are innovative training methods that help address that problem. So our work kind of falls into three main areas. So achieving FAA safety goals. Obviously, safety is always the overriding priority, and so you could argue that that has been maybe one of the reasons that things are so slow to modernize and change, is that there's always a lot of consideration for safety and what impact do those changes have on the folks that operate the air traffic system 24 hours a day, 7 days a week, 365 days a year. So I mentioned already some of the voluntary safety reporting programs. So AIAAS is the airlines are providing data to MITRE as the FAA's FFRDC. We anonymize that data, and then it can get analyzed to identify those hot spots or concerns. This program has gone through a couple of different phases. So as it enters AIAAS version 3.0, there's a look at how do we make this data available to stakeholders so that they can always also be analyzing it. Of course, a lot of incorporation of machine learning, AI capabilities to help identify. Don't necessarily require the human to look at everything, but can we identify some of the areas of concern requiring further study? Data-driven, of course, everything is data-driven. It almost goes without saying now. And so a lot of data-driven focus on safety coming from AIAAS, but also looking at how do we get that information to the folks that can apply the mitigations. Accelerating, also looking at how do we accelerate the certification of advanced air mobility vehicles. So still need to ensure they're safe, but recognizing that with the broad industry that's happening, there's a real urgency for these companies to be certifying their vehicles. We're hearing about that this week. But then also some of these companies don't have a long history of certification like companies like Boeing and Airbus do. So how do we speed up that process but still ensure safety? Authorization of space launches as well. So that's a really challenging problem for the FAA Office of Commercial Space. How do we make that process easier? How do we streamline it? How do we streamline the analysis? So MITRE's working with the FAA on that. And then pilot medical, also how are records kept? How do we manage the medical process too? And then mission assurance, so how do we ensure resilient operations for drones, new mobile technologies for digital departure clearances, for example, for general aviation. That's another area that we're looking at. Okay, efficient use of airspace is another area we're looking at. Today, the instrument flight procedures that are maintained across the U.S. at all of our airports, it's a huge inventory, and it's expensive to maintain, both from a resource perspective, from a continually evaluating perspective. We have a lot of procedures that rely on GPS, but there's also conventional navigation procedures that serve as a backup. And so this is, you can imagine, an ever-growing catalog of procedures. So there's a lot of discussion about both how do you automate some of the evaluation of those procedures. Are they being used? Are we keeping this procedure on the books because for 2 aircraft a year that use it? And so a lot of effort around managing that inventory more effectively. Increasing operational efficiency. So lots of work in the New York and East Coast corridors with their automation systems, and a lot of this is about process. So how do you schedule flights? What's the look ahead time for doing that scheduling? How do you make sure you aren't double penalizing some flights with delays? So that's a lot of existing capabilities, but making sure we're using them effectively. The FAA Command Center, which is the organization that determines kind of the NAS-wide plan based on weather conditions, special events, they have a lot of meetings every day. So there's telecons that happen with all the stakeholders. So these are airlines, these are the decision makers working at the FAA Command Center. You can imagine just a lot of voice communications that are communicating back and forth. So we're using some of the voice capabilities, so voice to text translation, and then also some natural language processing to see what can be gleaned and learned from those conversations that are happening on a daily basis. Integrating new entrants, so UAS integration into the airspace. There's a lot of challenges with operating UAS around critical infrastructure, for example. So there's new rules that are coming out, but then also technologies to identify when vehicles have encroached on that space. And then lastly, ensuring workforce readiness. So looking at how do we use data to determine the right level of staffing at different air traffic control facilities. And then part of this brand new air traffic control system as well is potentially consolidating some facilities, moving facilities to new locations. So there's a lot of human aspects to that, and wanting to bring data into really analyzing where those facilities should be and how they might be combined. And then lastly, one of our areas is operational advancement towards the future NAS. And you can see these aren't clean cut, because even in the last slide I talked a little bit about UAS, but this is an area where we're really looking at how do we improve the National Airspace System, how do we make it more agile so it can evolve more quickly and when new entrants are coming on board. So part of that is modernized software engineering. So one of the challenges is some of the systems in the FAA today are aging. They're complicated. They've been built upon for many decades. So how can we change software engineering practices so that those can be more agilely developed and we can deploy new capabilities into the airspace more quickly? Rapid acquisition and implementation. So this is a challenge for lots of government agencies, is how do we quickly acquire new technologies, new enterprise systems. And so lots of thoughts about how to do this effectively. One example that was recently employed in 2023, you all may remember when the notice to air mission systems went down, and this caused a nationwide ground stop. So this was a single point of failure. It was caused by an error in deploying a software update. And so that really caused, I think, the FAA and the aviation community to step back and say, one, how do we prevent that? But also highlighted a need to replace the NOTAM systems with a newer, more modern system. And so one of the things they did is they did a challenge-based acquisition where they provided a small amount of funding to start, and anyone could submit a proposal that they wanted to design the new NOTAM system. And there were a couple of down selects, and additional funding was awarded to further develop the system. But it's a really kind of new way in which you can do acquisition, where the government is working hand in hand with the vendors and then identifying really innovative and interesting solutions that they want to pursue. So that vendor was awarded, and we should be getting the new NOTAM system very soon. Data-driven engineering assessments, this is an area I'm working in personally right now, so looking at legacy capabilities. We're actually working with the FAA to do an audit of the legacy systems that were deployed prior to 2000. So this is leveraging data from the FAA to kind of identify which systems are a high priority for replacement or enhancement. And then lastly, spectrum and commercial networks. Obviously, communications is a really important area with all these new entrants, for example. And so looking at how spectrum is allocated across different applications. I have a colleague that's doing some research around how you can use commercial wireless networks for command and control for UAS, and testing whether different implementations of the use of those commercial networks ensure connectivity. So a lot of work in that area. So in addition to supporting the FAA, we do have an international presence as well. So MITRE has worked with over 55 international sponsors over the years. We have a MITRE Asia Pacific Singapore office, where we do projects with Singapore, and part of that effort is also to train their workforce to do this type of work. Recently, we did a concept of operations for urban air mobility operations in South Korea, so that's another example of some of the international work that we do. More recently, we've been doing some state-level advanced air mobility initiatives. So you can imagine there's some FAA-level work that has to be done from a regulatory and kind of standardization process. But a lot of the states are off and running. They want to see how AAM solutions are going to impact their state. They have a lot of interest on where those operations might support rural communities that are underserved by legacy aviation or might be geographically constrained, might have some medical applications as well. So MITRE is working with them, helping to bring expertise from our work with the FAA to help inform the roadmaps and really the technologies these states need to support their objectives. And then we are starting to work a little bit more across the Department of Transportation. So while we've traditionally been focused on the FAA, we've also started to look at multimodal transportation options. That's obviously a topic at the conference this week. So how do you do that last mile of that first or last mile to your transportation solution, and then or maybe package delivery, for example. And that is spanning automotive, rail, and transit. We're also looking at scalability of data, so sharing data across transportation platforms, both from a safety perspective, but then also from this multimodal and innovation perspective. And then lastly, resilience is obviously a huge concern. Resilience from a security and safety perspective, as well as a climate perspective. So what transportation is at risk, and how do we recover from disruptions to our transportation networks quickly? And you can imagine that, the aviation industry is kind of the benchmark from a safety perspective. So part of what MITRE is trying to do is to bring that expertise from aviation to other modes of transportation and other industries.